All right, hey students, here we are with a video here to help you study for your midterm. Now this is the same PowerPoint that I used for yesterday for our fun game, which we didn't get to finish. So in this video, I'm going to finish making sure that you study for this complete midterm getting ready. So just a reminder, when you come in on Monday, you will have the multiple choice only section, which I think you'll do fantastic. On Tuesday, you're going to have the short responses, and for the rest of the week, you are going to be responsible for having a completion of independent work. And then when we come back after midterms, we're going to go back into our wonderful science lessons with labs, of course. Now, shout outs to all of the students that went to extended advisory. Shout out to Rico, shout out to Masai, shout out to Elijah, Scully, and Andrew that all came to office hours, and now they are doing a really good job in class. Now, good job for you for tuning in and playing this video, because you are now 90 steps ahead to passing the midterm exam. Now, in your do now, I asked you to understand what abiotic factor, biotic factor, homeostasis, and organic molecules are, because these are the kind of terminologies that I think most students forget. Now, just a reminder that abiotic factor are non-living things that affect the environment. Don't say rocks. You have to think of big picture things that affect living things, that if we don't have it, or it changes, or something drastic happens, it affects the lives of living things. For example, abiotic factors that affect living things: weather, water, oxygen, sunlight. Those are the main ones. Okay, if we don't have any sun, we do not have life, because all life originates from the sun. If we don't have water, we don't have life, because water is the source of life. We're made up of 70% water. Biotic factor are all living things. And here's a little trick though. Sometimes they ask what are some biotic factors that can affect living things. So you can say things like diseases caused by pathogens, like we get sick because of bacteria. Bacteria is living. So that is something that affects living things that can cause diseases. So bacteria is living, and bacterial infections cause diseases, which can eventually cause death in living things, or just make them off of their homeostasis. This is the word that a lot of students forgot, because we learned about homeostasis in September. Homeostasis is the balance, equilibrium of all living things. Right now, you're at homeostasis because you're not sick, you don't have organ failure, you don't have a fever. Hopefully you don't have a fever when you're seeing this video. You're not sick, you're fine. Your body is at homeostasis. When a body or living thing is not at homeostasis, that means that they're sick, that they have organ failure, that they have a pathogen or a disease, some kind of disease, they have some kind of abnormality, they're not at homeostasis. So you are going to have a question asking you about why is that living thing not at homeostasis, and it'll be in the reading. It's a reading comprehension. What is an organic molecule? An organic molecule are molecules that contain carbon and hydrogen at the same time. At the same time, ladies and gentlemen, okay? So we'll get back to that. What you need to bring for the midterm is a pen, a really smooth gel pen, black or blue ink only, a pencil. A ruler and calculator might be provided. In terms of the calculator, you'll have a calculator. With the ruler, we're going to try to have it, but if you have a ruler at home, please bring one at home. So, congrats to all who played basketball. Good job. That was a lot of fun. As long as we behave and we're doing what we're supposed to do and you guys don't go cray in the classroom, we will continue to have fun and play basketball. And I heard that you guys really like these things. I will always change up the prizes, so next time will be something different. So let's move on to understanding what you need to do for the exam. So one of the things that you need to learn and relearn is lab safety. You are going to have many questions on the midterm that ask what is wrong with this picture, or what do you need to have when doing certain labs. And we already know that this guy, two things is going on. He doesn't have goggles, and he does it, and this thing which he is boiling, a test tube, needs to be put on the other side facing away from his face, because if this is heated up a lot, it splashes into his eyes, and then that's no good, and then he's injured. So no goggles, and anything burning has to be put on the other side. Okay, next. Now this was part of the game. An average is taken when you add all trials, and you get a number and you divide it by 3, and then you get an average. You were asked during the game which one was an incorrect average of these trials. So this student 1, got these 3 numbers and then got this average was correct. This student got these 3 numbers and then got it correct. Now, student number 3 got an average of 60.3, 60.5, 60.5. The average could never be 61 because he never got 61. So how could his average be 61 if he never reached that? So this one is the incorrect average. For number 4, this student got these 3 trials. You add all these numbers and divide by 3, and then got the correct average. And it makes sense. 59, 55, 58, add all 3, total divide by 3, and then you get an average. You will be asked to get averages on part 2 of the midterm. Homeostasis. So homeostasis is an internal where Okay, so let me just repeat what I said about homeostasis because the video got kind of choppy there, and I probably edited. So with homeostasis, homeostasis is having a stable internal environment in an organism. So the organism's body is stable. The organism is not sick. The organism is not dying. There's no disease. There's no organ failure. They're not sick. They do not have a fever. There's no pathogen. The blood pressure is stable. Plants are doing fine. They don't have bacterial fungal infections. So homeostasis is a stable internal environment. No one's sick. So that's something that you have to remember. There is a homeostasis, there's a homeostasis question that asks you what's wrong with this particular organism. I think it's a plant, a banana plant, and you have to explain what is making it unstable, what's making it sick. So make sure you read carefully and answer the question carefully. Okay? So moving on, in terms of this worm. So in terms of being able and understanding how to measure things, how to measure objects, how to measure specimen, using the ruler, using measurement. So here I asked in class, what's the length of this worm? The length of this worm is 9 centimeters. Now, some of you just measured straight from where it was, which is incorrect, but what about all this space here? So this is inaccurate if you were to put 10.5. Some of you said 10.4, which is incorrect. It's actually 10.6 where it stopped. But what you can do is you can look at where it's at right now. This is 1.56, and this is 10.56. So if you take 10.56 minus 1.56, you get 9. So also, you can just hop. Hopping means you look at the distances between one point and the next, and you count that as one metric measurement. So here we know that from here to here is 1 centimeter, and all of these spaces are the same distance, the same little distances. So we know that from this point to this point, it's 1 centimeter. So you can hop. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9. This is exactly 9 centimeters. But the question is probably asking for the results in millimeters. So just know that 1 centimeter equals 10 millimeters. So 9 centimeters will give you 90 millimeters because you would take 9 and multiply it by 10 to give you millimeters. You have to be very careful as to what you're reading, what the unit is, and what the question is asking for. Take your time with directions, okay? Next, what is the exact temperature? So we know here that this is a thermometer. It's measuring for temperature. And here we have that it's going by 20s. So here's negative, very cold, and here's where it gets a lot warmer and very hot. So here you go, 20, 40, 60, 80, right? It's going by 20s, and you see that the thermometer stopped between 0 and 10. Well, what's half of 20? Half of 20 is 10. But you're not just going to put 10 because you're going to have a multiple choice to choose from. So it's 10 degrees Celsius. Here we have a graduated cylinder. We're going to be using graduated cylinders a lot. And know that you measure from the curvature of the water, not the corners. That is not the accurate measurement. So if you're looking at this, you know that it's going by 5, 10, 15, 20. And these individual measurements are by 1. So 1, 2, 3, 4, 5. And they put the 5. 6, 7, 8, 9, 10. And they put the 10. Let's see, be very careful. This is where it ends right here. The curvature is hitting this one. So this one's 10, 11, 12, 13. So this one is 13 milliliters. And we know it's milliliters because we have the unit right here. Now we have to name an abiotic factor in this picture. Now you guys did very well. You know that abiotic means non-living. So let's just move this picture over and let's move this over. And we know that abiotic factors don't say cars, rocks, a cup. You have to speak about the big picture. Speak about things that affect living things. So the things that are abiotic that affect living, I feel like I already did this. Hold on, let me just make sure that I'm not repeating myself here. Oh, I did. I did when I did this, when I spoke about the abiotic, but let's just do it again. So let's list them. Abiotic factors that affect living things. Sunlight. It could be the lack thereof or too much sunlight. Then we have the, oh my gosh, I'm blacking out here. Weather, light, same picture. Let me move this over and let me do this. So biotic factor, if we were to do this and I would have A and hydrogen at the same time is found in living things. Both, they need to have both. So what are two elements found in organic molecules again? That's carbon and hydrogen, C and H. And now that we're here, I'm actually going to go ahead and bring this one up since we're on the topic of organic and inorganic. This is a picture that I copy and pasted, so I can't really type here. But we're going to name if they're organic or inorganic and why. So H2O, water. It's inorganic because it doesn't have carbon. It has the hydrogen, but it doesn't have the carbon. So this one is inorganic because it does not contain carbon. CO2, carbon dioxide. This is inorganic because it only has carbon. It has to have both carbon and hydrogen. That's why it's not organic. This one is carbon monoxide. This one is inorganic because it doesn't have hydrogen. Number 4 is organic. We finally got one, specifically glucose. This is glucose sugar. So this one is glucose sugar, and it's organic because it has carbon and hydrogen. But one of the things that you also have to remember is that sugar is made from living things, and that is an organic molecule. So now let's discuss the four types